A long, long time ago, King Herod II of ancient Greece summoned a jeweler to make himself a crown out of pure gold. However, the king soon became distrustful of the jeweler and wondered if the crown was really made of pure gold. To answer the question, the king summoned his most trusted advisor, Archimedes. The king told Archimedes to figure out whether the crown was indeed made from pure gold. He knew that finding its density would be the answer, but how would he find its volume, which was needed to calculate its density?
So what is density, and why does density matter? Well, density can be thought of as how compact a material is. In other words, how much material is in a substance and how much volume does that material take up. We have right here a pile of cotton balls and a very small amount of modeling clay. If we put both of these on a scale side by side, we see that both the cotton balls and the modeling clay weigh 10.1 grams. Because they have the same mass, the material in the modeling clay is much more compact than the material in the cotton balls. Therefore, the material in the modeling clay has a higher density than the cotton balls. Now, if we look at the actual equation for density, density equals the mass, which is measured in grams, divided by the volume, which is measured in centimeters cubed, and volume is traditionally found by multiplying the length times the width times the height. We can also visualize density with another experiment that we have here. We have 4 canisters here of different materials you can find around the house. So you can try this experiment at home if you like. In this first one we have cotton, this one we have tea, and this one we have sprinkles, and this last one we have honey, which is my favorite. So if we put each of these into the bath of water, we should see them float at different heights because the density between these materials is different. So cotton floats very high in the water. Tea floats a little bit lower. We add in sprinkles, and finally honey. Whoa. So because honey sank to the bottom, it has a very high density, much greater than water. The cotton balls, on the other hand, are floating very high and have a very low density, less than water. Now, density is a material's property, so it doesn't matter the shape of an object or the size of an object. If it's the same material between 2 different objects, it's going to be the same density. For example, the cotton balls that we have here have the same density as the cotton balls from the first experiment. So because the density doesn't change between a material, it's very good to identify a material if you know the density. Finally, in this last experiment, I'll combine equal parts of honey, water, and oil into this glass. And we see 3 layers form. On the bottom is honey because it has the highest density, in the middle is water, and on the top is oil because it has the lowest density. So how did Archimedes find out the density of the crown? Well, we know Archimedes must know the mass of the crown because that's relatively easy to find. But how did Archimedes figure out the volume of this crown if he couldn't measure the length, width, and height of the crown? Well, let's find out.
Archimedes thought and thought about how to measure the volume of the crown to find its density. After much deliberation, he decided to take a break by taking a nice, hot bath. However, as he stepped into the bath, it dawned on him for the first time that the water level rose to offset the volume of his body. He knew this was the answer he was seeking, and he said, "Aha, yes!"
Now we know how Archimedes found the volume of an irregularly shaped object. That is, he realized that if he placed this object in a liquid, the amount of liquid it displaced is equal to its volume. So now that we know this, let's try this experiment for ourselves to see if Archimedes was right. So first, we have a miniature version of the king's crown that Archimedes used. First, we're going to determine the mass of this object by placing this on our scale. This miniature crown has a mass of 93.7 grams. Now, let's find the volume of this object. And so first, we filled up a glass full of an orange-colored water, and we filled it all the way to the brim. And now, when I place this crown into the water, now we see it, all the water down here overflowed and is collected, and now I need to carefully take out this inner glass. So with the help of a napkin to take up some of the excess water, I'll carefully remove the glass. Presumably, the volume of liquid that's in this container equals the volume of our miniature crown. So now I'm going to very carefully pour this water into our graduated cylinder so we can measure its volume. And here we go. So it looks like we are right at about 64.2 milliliters. And so now we know the volume of our miniature crown. The volume is 64.2 milliliters, which also equals 64.2 centimeters cubed. Let's see if Archimedes was right by reshaping our modeling clay, our crown, into a cube shape so that we can measure its length, width, and height with a ruler. So now that we've smashed up our miniature crown, let's take its dimensions. Using our ruler, we see that the length is about 4.4 centimeters. Its height is about 4.4 centimeters. And its width is about 3 centimeters. Remembering that volume is the length times height times width, and multiplying all of these values together, we find the overall volume is 58.1 centimeters cubed. Now, accounting for small experimental error, this value is very close to the value found by the water displacement method, which proves that Archimedes was right. So now Archimedes realized the volume of the gold crown using this method, and when he did,
he ran through the streets shouting, "Eureka! Eureka!" For he found the crown was not made of pure gold. The jeweler had cheated the king, and Archimedes proved it by determining its density.